Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another important question for system designing interview. And the problem or the system that we will be discussing today is a very important topic, and that is the designing of a EdTech platform like Udemy or Coursera. And believe me, this question is actually very important, because if you have followed my YouTube community post, you must be knowing that very recently I have gone through the interview process of Google as well as Microsoft, and in one of the system designing round, and I was asked more or less a question on the same topic. So I won't tell it was the exact question like design Udemy, but it was a flavor of the same thing. So if you know this question or if you know the solution of this problem, you can definitely clear that interview. And just to give you a heads up, I have cleared both the interview. So what had happened on those interview and how was my complete experience while I was going through the interview process with Google and Microsoft? For that, I will be creating a separate video where I will be telling in detail that how was the experience with each and every interview, what is the expectation, and what are the resources you should be using to crack those type of interview. But before discussing all those things, let's focus on today's topic of designing a edtech platform like Udemy. And here I will tell you in detail that how was the feedback on that interview when I was designing this platform and what was the follow-up question. So without wasting much time, let's get started. So I hope you guys are already familiar with that what is a edtech platform like Udemy or Coursera. So it is just an online tool or an online platform where multiple instructors across the globe can upload their videos, questions and assignment and everything. And once the user purchase those things, they can go through all the courses and the materials that are given in the course. So that is the main ask for this question. But believe me, this problem statement that designing of Udemy is a very easy and a straightforward question. But the problem is this is actually quite a worse thing if you start with the designing, because here we have multiple actors who are actually interacting with the system. For example, we have the user who are getting the lessons. After that, we have the instructor who are uploading the course and all the question and the assignment. And there are one more party, and that is a moderator or a admin panel, which actually checks all the content uploaded by the instructor before publishing it to the internet. And since there are a lot of actors that are involved within this design or within this application, so obviously there will be a lot of flows that get involved when we will be designing. And that is why it is very crucial to discuss with your interviewer that which aspect or which side of the platform he is interested that you should design. So keeping in mind all the vastness of the system, today in this video we will be first discussing the main core concept of Udemy, that is the user flow as well as the instructor flow, means how the video and the contents are getting uploaded in the backend. So these are the two flows that we will be discussing today. So let's start with the first step of our system designing interview, and that is the gathering of the functional requirement. And the functional requirement of this system is quite simple. That is, the user or the student will be able to create an account in our application. Number two, user will be able to search, select, browse different courses based on the rating, difficulty or the price level. Number three, when the user or the student enroll to a particular course, he should be able to track his progress, means how much percentage of the course he have completed. Number four, there should be assessment system in the form of the quiz as well as in the form of the assignment. Number five, each and every course should have a review and the comment section, because obviously without seeing the review and the ratings of a particular course, it is very difficult for the user to identify that which course is actually good and which is reliable. So the comments and the review of a particular course is very important. So these are all the 5 to 6 functional requirements that we have to solve in this problem. But apart from this, we have to also consider few of the functional requirements of the instructor. Means we have to take care of how the instruction onboarding will going to perform. Number two, how they will be uploading videos, content, quiz, assessment and all these things in the backend. So these are more or less all the 6 to 8 main core functionality that we will be solving in this problem. So let me first write down all those things so that it will be easy for you to understand. So here you can see these are all the functional requirements that we will be solving in this problem. So these all are from the user aspect and these two are from the instructor aspect. But apart from this, there was one more functional requirement that was asked during my interview as a follow-up question. But what was the question and how we will be implementing that? That we will be discussing once we are done with this designing. After that, I will tell you how that enhancement will be done. So stay tuned. So since here we are done with the first step, and that is the gathering of the functional requirement, let's now move to our next step, and that is the non-functional requirement. And as you know, non-functional requirement tells that the characteristics of the system. So let's first see that what are the non-functional requirements that we should keep in mind while designing our system. So the first and the foremost non-functional requirement that you have to collect from your interviewer, and that is the scale of the system. Because knowing the scale of the system is very much crucial, because based on that we take some of the crucial designing decision which is very important while designing. So the first and the foremost thing is the scale of the system. And when you will be asking your interviewer that what will be the scale of this Udemy platform that we are targeting, so at that time your interviewer will be telling that this application have more than 100,000 crores and the total number of users means the student is around 1 million. So this will be our first non-functional requirement. Now the next important thing, that is the cap theorem. And as you know, right now that cap theorem tells that whenever you are creating a distributed system, then you have to either compromise between the high availability or high consistency. A system or a part of the module cannot be highly consistent or highly available at the same time. And here you can easily see that since here we are targeting millions of users across the globe, so obviously we have to go with a distributed system. And whenever we are telling about the distributed system, so obviously at that time partition tolerance will be implicit. So here, based on the cap theorem, if you understand it clearly, we have to give the availability of the system much more than the consistency. Let me tell you why. So here, if you look into our application clearly, what it is expected that whenever a particular user want to see a video, the video should get rendered as soon as possible, and also our application should be up and running almost all the time. And that is why the availability of the system should be more than the consistency. And here when I'm talking about the consistency, I mean that for example a video or a content get uploaded by your instructor, then it is not required that at the 0th moment the course will get published globally across all the users. Because if you understand the flow, once a particular instructor uploads something on the Udemy platform, it first go with a validation. So it is not possible that whenever you are uploading something, it will go to your global audience. And that is why here the consistency of the system does not matter. And that is why we will be giving the priority of the availability more than that of the consistency. But there is one point, and that is the payment gateway, where we have to give the priority to the consistency rather than the availability, because it is expected that once a particular user or a student buy a course from our platform, it is responsibility of us to give him or her the access to that course. So it should not happen that the student purchase the course and after a few minutes or so we are giving the access to that user. It should happen at the 0th second. And that is why on the payment flow, or where we are giving the access of a course to a user, that flow should be highly consistent. I hope I'm clear with that which part of our system should be highly consistent and which part of our system should be highly available. So let me write that part over here. Number 3, our system should support a large file. So for example, an instructor is uploading a video of 1 hour. So we have to support that huge file in our system, or there can be some of the assignment which is quite a huge. So all those huge amount of file or those large file should be supported by our system. So here this will be our third requirement, and that is the system should support large file. Now the next non-functional requirement is like if a particular course is a video course, then as soon as a user play that course, the video should get streamed to the user with nominal latency. And here when we are telling about the latency, we should quantify that, and that is within 2 seconds. So here you can see these are more or less all the non-functional requirements that we have to keep in mind while we will be designing our system. So here if you see, we have almost completed the first step of our designing, and that is the gathering of the functional requirement as well as the gathering of the non-functional requirement. Now, since we are done with our first step of our designing, let's go into our second step, and that is the identification of the core entity. And as you know, identification of the core entity is quite easy if you have written the functional requirement properly. So let's see what are the core entities that we can identify as of now in our system. So here if you go through all the functional requirement clearly, here you will be seeing that these are more or less all the core entities that we can list down as of now. So here at the very first we are having the user, or we can say we are having instructor. After that we are having the courses, the payment, the review system and the progress. So these are more or less all the core entities that we can find out just by reading all the functional requirements that we have pointed over here. It can easily happen that there are plenty more core entities that are involved in our system, but as of now, just by understanding or going through the functional requirement that we have gathered, these are, I think, more or less all the core entities that we can identify as of now. Now let's go into our third step of our designing, and that is the API designing. And believe me, for this problem statement, API designing is not that much crucial because the API REST endpoint that we need for designing this application is quite simple and straightforward. And that is why during my real interview also, my interviewer told me to skip the API designing for this problem. Because as I always tell you, during your interview, you only have a 45 to 50 minutes in hand to design all of this, and it is not possible to cover everything at that time. But since we have a lot of time right now, and since this is a video, I will be going with our next step, and that is the third step of our designing, and that is the API design. So let's see what are the major REST endpoints that you should point out over here if your interviewer asks you during your interview round. So here if you look carefully, these are more or less all the public REST endpoint that you need for designing this system. So the first one is all the API that are needed for the courses. So here you can see the first API endpoint here is nothing but a search API where you can find the codes from our database by giving different query parameters like category, price, rating, level and all these things. And since here you are retrieving information from our database, so obviously this will be a get URL. Clear? After that, obviously when you are opening a particular course or a particular video, what we see all the information regarding the course, means who is the author of that course, what are the chapters that are there in the course and all these things. And for that, here we are having our second URL, that is the course followed by the course ID. So whenever our backend receives a particular course ID, and then it will give in the response all the course details. Clear? Now the third endpoint that is needed is for the instructor, that is who are submitting a course in the backend. And since here you can see we are saving an information, and that is why it is a post URL. Similarly, once a course get uploaded in our backend, so obviously there should be a moderator who will be validating a course, and once it is validated and it is fine, then they will click on publish so that it gets visible for the global audience. So here we are having our fourth endpoint, and that is the publish endpoint. Clear? So these are all the endpoints that are required for manipulating with the courses. After that, here we are having the progress. So if you have seen that in our function requirement, we have taken a point into consideration, that is the student should be able to track their progress. And to facilitate that, here we are having our two endpoints, and that is one is the post endpoint which actually submit their progress in our backend, and then we have our next endpoint, that is the get endpoint, which retrieves that what is the progress of a particular student on a particular course. Now the next important endpoint, and that is the enrollment endpoint. So for example, you want to purchase a particular course, what you have to do? You have to enroll to that course. And a course can be of two types. It can be a free course or it can be a paid course. So whenever it is a free course, there is no payment gateway or a payment system that get involved in our system. But if there is a price that is associated with a course, so obviously there will be a call that will go into our payment gateway and the payment system. From that, all the validation will be done, and thereafter you will get enrolled to that course. And to do that, here we are having our post endpoint, and that is for enrolling a particular course for a particular student. Clear? Similarly, from the instructor point of view, if the instructor want to see that who are all the students who have enrolled to a particular course, then we are having our second URL, that is this one. And at the last, if we want to see that what are the courses that I have enrolled, then we are having our last endpoint, that is our enrollment endpoint. So here you can see these are more or less all the endpoints that are needed, or all the REST endpoints that we need to design this system. There can be plenty more endpoints that you can define over here to manipulate each and everything. But obviously, if you keep on writing all those endpoints, it will be a very time-taking activity and you could not complete your entire designing within time. So I will better tell you, do not go into the detail of all the endpoints or everything that is needed for this designing. Rather, straightly jump into our fourth step of our designing, and that is the high level designing of our application, where we will see that what are the major component or what are the primary module which we need to introduce in our system to fulfill all the functional requirement that we have gathered. So let's go into the fourth step of our designing, and that is the high level designing of this application. So the high level designing of this application is actually quite simple and straightforward if you have seen my earlier videos, because the concept is more or less same. Only thing, how the data flow happens and how we are interacting with the service, that is actually the major concern. But I will just give you a heads up, if you are coming to my video for the first time, I will tell you to go through two of my videos from my playlist. Number one is how to design an OTT platform, and number two, how to design a Google Drive. Now, why I'm telling that these two videos are important, because here if you understand that, here, this entire platform deals with documents as well as the video. So how the videos or how huge documents are getting uploaded in the backend in the form of the chunks, and how you are rendering those huge video to the front end, those concept is actually needed if you want to know this thing in detail. And that is why you should go through my two videos, that is the OTT platform designing and the Google Drive designing. So that being said, I hope that you already know those concepts. Let's start with the high level designing of this application. And the first and the foremost concept that we need in this system, and that is the user or the student. So here what I will do, I will introduce few of the users or the students over here. And obviously, since this is a microservice architecture, and that is why to handle our load evenly, we need a load balancer or a API gateway at the very beginning of our application. And I hope by now you already know that what is the role and the responsibility of the load balancer and the API gateway. That is distribution of the traffic uniformly across all the backend services. After that, routing of the traffic, and number three, authentication and authorization of the system. So here you can see we are done with the first step of our designing, and that is designing of the user who are actually interacting with our system, and the load balancer and the API gateway before the request comes into our backend. So here if you look carefully, the first requirement that we have got is like the user should be able to onboard in our application. And as you know, when we are doing an onboarding of the user, what we need? Here we need a user service for the user onboarding. So here we will be having our user service, which will be completely responsible for onboarding all the users in our application. And whenever you are onboarding a user into application, obviously we have to save those information of the user somewhere. And that is why here we will be having our database, that is the persistent storage unit. So here we will be having our user database. Clear? So all the requests are coming from our load balancer and the API gateway. And here if it is a user onboarding or a login URL, so the request will go into our user service, and thereafter it will go into our user DB for the fetch or for the saving of the user metadata. Clear? Now let's see what are the other function requirement that we have to solve. So the next function requirement, you can see that users should be able to browse filter course based on some criteria. So obviously here to fulfill that, we will need our second service, and that is the course search service. So here we will be having our next service called as the course search service. I hope this is clear, but the question is from where this course search service will search the result. And for that, what we need? Here we need a database or our master database called as a course DB, which have all the information of the courses. So here we are having our course database, and from this course DB, our course search engine will make the query over here and will give the response to the front end. I hope this is quite simple and the straightforward implementation. Now the next thing is like the user should be able to enroll in a course and track the progress. So here to do these two operations separately, I will take two services separately. One is the enrollment service whose main responsibility is enroll a student on a particular course. So here we will be having our next service called as the enrollment service. And the next service that is needed is for tracking the progress of a particular user. So here I will name it as a user progress service. Now here if you see, what actually happens that whenever your particular user is trying to enroll to a particular course, it might can happen that a course is a paid course or it can be a free course. Now, if a course is a paid one, then what we have to do, we have to call our payment service for making the payment. So here what I will do, here I will introduce one more service called as a payment service. So for example, the student want to enroll for a free course. Now, if you want to enroll for a free course, what will happen? The request will first come into our enrollment service. And since this is a free course, means there is no payment that is needed. So what we will do, we will simply save that information in a simple database. Let's name it as a course enrollment DB. Means here since there is no money that is associated, so once the user enroll for a particular course, here we are saving that information in this database. Means for a particular course, this is the course ID for which he have enrolled. So here we are having a mapping object in this course enrollment DB. Clear? But if the course is a paid course, then what will happen? We have to involve our payment service into it. Means we will redirect our user into our payment gateway, and from there the payment service will handle everything. I hope I do not need to tell in detail that how a payment gateway or a payment system actually works, because I already have published a complete designing video on this payment system or a payment gateway. So feel free to check out all those things. So just to give you an idea, if the course is a paid course, the request will first go into our payment DB, and once the payment is successful, what we will do, we will capture that payment related information in a separate DB called as a payment DB, as well as we have to update this course enrollment DB. That is, the user have made the payment for this course, and that is why right now the user is enrolled to that course. So here there will be two requests, one going into our payment DB and another going into our payment enrollment DB. Clear? Now since you have understood on a high level that how a particular user is enrolling to a course, now let's see what are the things that will happen once a user is enrolled to a course. So what will happen once a particular user purchases a course, that course belongs to that user. Now whenever he wishes to open that course, if it is a file or a video format tutorial, the request will go into our backend service called as a playback service. So for example, for in case of the Udemy, most of the courses are the video courses. So here we will be having our next service called as a video playback service. And once the request comes into our video playback service, means our client is asking for that particular video to be rendered on the front end. So what will happen? We have to search it from somewhere. And as you know, where we save all the heavy files like a video file or the image file, that is in the blob storage. So here obviously there will be one more storage system, that is nothing but a blob storage, where we will be keeping all the MP3 file, all the video file of the course. So here the payment backend service will call this blob storage, and it will fetch the corresponding video from there and it will render it to the UI. Clear? Now here you can see we have almost covered all the functional requirements that we have gathered. Only two things that is pending, that is the progress tracking, and number two is the review and the rating system. So here you can see, here we are having the user progress service, which actually store all the progress of the user. Means for example, I'm done with 70% of the course, or I have seen 30% of this video. So all this metadata of how I have progressed on a particular course, those information will be captured by the user progress service. And obviously, since we have to save all this information, so there will be also a database associated over here, and let's call it as a progress database. And the last but not the least, what we need here, we need a review and the comment system for each and every course. So here for that, what I will do, I will introduce another service called as a comment and the review system. And obviously, since all this comment and review are associated to a particular course, so all this information I would like to save it in our course database so that it will be easy for us to search all the information regarding the course, comment and everything from the same DB. Clear? So here if you look carefully, we have almost covered all the functional requirements that we have considered at the very starting of our interview, and we have managed to solve all of them. Only thing that is pending, that is the second phase of our development, that is the instructor point of view. So here if you see, we have only taken all the functions and related service that are needed for the user onboarding or the user playback service. We are not at all considering that what are the things or what are the services that need to be there for the instructor to upload video in our backend. And for that, to show that part of our designing, I will introduce one more load balancer and the API gateway over here. And this load balancer and the API gateway will be responsible for handling all the traffic coming from the instructor or the course creator. So here we will be having some of the user who are nothing but the instructor over here. And here if you look carefully to this part of the system, here instructor have two basic role to do. One is uploading the course into our backend, and for that we need our first service, and that is the catalog service. Means with the help of this service, the instructor will upload all the metadata of the courses. Means what is the course, and all this metadata and the description related information will be uploaded with the help of this course catalog service, as well as all the questions and the assignment will also get uploaded via this catalog service. Clear? But you have to remember one more thing, that the instructor can also upload a video file or a huge image file or an assignment file. And we cannot save all those heavy files in our course database. Rather, what we have to do, we have to save all those information into our blob storage. And for that, to upload all those heavy files, we will be having another service called as a media uploader service. And its main responsibility is uploading the heavy file into our blob storage. So here all the requests are coming from the instructor into our load balancer and the API gateway, and based on the endpoint, our API gateway will route the traffic between the catalog service and the media uploader service. I hope this is clear that how we have segregated the two parts of our designing. One is the user part and another is the instructor part. So here if you just look carefully into this entire system, here what is happening, the first and the foremost, this instructor is updating a course or uploading a course with some metadata and all these things with the help of this catalog service. And once all those things are uploaded, what he will do, for each and every tutorial or the course, he will be uploading the video or the image file in our system, which is done by the media uploader service. And those things are uploaded in the blob storage. Now, once all these things are done, what happens, like the course after get validated by the moderator, it will get published globally for the entire Udemy students. Now what the user or the student will do, he will be first registering into our application with the help of the user service. Now once that is done, he can find a particular course with the help of a course search service. And what this course search service will do, it will scan all the courses that are available within the course database that have been uploaded by the instructor. Clear? Now, if the student is happy with the course by seeing all the review and the comments of a particular course, what he will do, he will try to enroll to that course. And there are two ways by which he can enroll. One is the free enrollment if that course permits, and then at that time the request will first come into the enrollment service and the information will get saved into our course enrollment DB. But if it is a paid course, then what will happen? The request will go into our payment service, and once the payment is completed, then only the course will get enrolled with that user ID. Clear? Now what will happen, once the user start with the preparation or start with going through the course, all the progress of the user will get tracked over here with the help of the user progress service. I hope this is clear that how the entire flow is working over here and how we are fulfilling all the functional requirements that we have gathered right now. But the things are not at all simple the way it looks like. Because here if you look carefully, I have abstracted lot of things over here because the way the video files are getting uploaded in the blob storage is not actually true. Also, the way the video file is getting fetched from the blob storage is also very abstracted. So here in this designing, that is in our high level designing, though we have covered everything, but we have not discussed in detail how each and every component will interact with each other and how we will scale this database, and a lot of things we have to discuss if we need to design this entire system correctly. So let's go into the last step of our designing, and that is the deep dive designing, where we will see in detail that how each and every component will interact with each other, how we will be doing the mapping between the codes and the persons who have enrolled, and all those things we will be discussing in the next step of our designing, and that is the deep dive design. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the deep dive designing. So the first thing that I will do, I will copy this entire designing from the high level section into our deep dive designing or the low level section. And let's now start with the first component that we have introduced, and that is the user service. So here if you look carefully in the deep dive design, here we have mostly covered all the services that are required to fulfill all the functional requirements. The only thing that we will see right now is how each and every service will interact with each other, how the data will get saved into the database and fulfill all our non-functional requirements. So let's start with our first service, and that is the user service. And as you know, the user service is quite simple and straightforward. Here we are having a user service, and this user service will be responsible to capture all the user metadata, starting from the username, user ID, password, date of birth, and all the metadata that are needed for profiling an user. So let's see how the schema structure of the user DB will look like. So here, as you know, the user DB is a flat relational database, and that is why we will go with a Postgres or a MySQL solution. So let's see how the schema structure will look like. So here if you see, this will be the schema structure of the user DB. So this is a very simple, that is here we are having a user ID, name, email ID, phone number, password, status of the account, and other metadata that are required for the profile. So here we are done with our first service, that is the user service, which is very simple over here. Now let's go into some of the main component of our system, and let's go to the first main component, and that is the course search service, by which they can filter out all the courses from our database. So let's see how this entire flow will look like. So here if you look carefully into our functional requirement, we have told that clearly that users should be able to browse, search and filter course by category, difficulty, rating and price. So here if you see, there are a lot of metadata that are involved while they are searching. Means there are a lot of filters that are getting associated. Moreover, there is one more important thing, that a particular user can search a course based on the title, and the title can be anything, means it is a textual search. And whenever we are going with a textual search, then obviously we cannot rely on a normal search, rather we have to go with an Elasticsearch. So let's see how we will implement an Elasticsearch in this flow. So the first thing what we will do, I will decouple this entire system, that is this course search service will not call directly this course database. Rather, it will be called by the Elasticsearch. So here the course search service will internally call the Elasticsearch over here, and it will not directly call the course DB. So I will introduce one more service over here called as the Elasticsearch. I hope this is clear, but the thing is like there are a lot of filter criteria by which this search result will come. It will be with the help of the category, difficulty, rating, price and all of these. And all those tables are basically a segregated tables, means For example, we are keeping the rating in a different table, we are keeping the comments in a different table, we are keeping the titles and the metadata of the course in a different table. So it is not possible that on the runtime, when you are searching a database or you are searching the course, you will join all the tables together to find out the meaningful result. So it is not actually a feasible design pattern, because if you keep on joining on each and every query, then obviously your search time will increase significantly. So what we have to do, we have to pre-compute everything and we have to ingest it in the Elasticsearch database so that the searching time decreases significantly. So let's see how we will do it. So here, if you look carefully, we are having our course database, which have more or less all the information about the course. And what are the information that are there in the course? We will discuss it very soon. Now, if you have seen my earlier videos, you must be knowing that this search engine, that is the Elasticsearch, cannot work all alone. It needs the actual data on which the query can be made. And for that, what we need to ingest all the data from the course database into this Elasticsearch, so that both of the tables of the Elasticsearch as well as the course DB will be in sync. And for that, what we have done in our earlier videos, we have introduced a CDC pipeline so that whenever a new data comes into our course DB, a pipeline gets invoked and those data will be fetched and will get synced with the Elasticsearch database. But here we have to do something more. That is, instead of just only writing a CDC pipeline, we also have to write an aggregator platform. Means here, what I mean to say, here if you look carefully, this course database will have a lot of tables, and during the runtime it is not possible to aggregate everything together. So what we need, here I will introduce one more service called as the aggregator CDC pipeline. So you can name it anything you like. So let me just write it over here. So this service, what it will do, it will take up all the data from the course database, it will join everything together, and once it is done, thereafter it will post the complete JSON file into this Elasticsearch database, which can be easily read by the Elasticsearch. So you can easily understand that when a particular user is trying to search a course using some filters or comments or anything, this Elasticsearch will already have all the pre-computed data in his database, and thus it can easily apply its Lucene search and whatever the internal logic to give the result in the most optimized time. I hope this is clear. Now what we will do, we will proceed a bit forward. Means we will first see that how the instructor is uploading the video and the content into our website. Means into the Udemy platform, because until and unless we do not know that how the instructor are ingesting data into our application, it will be very difficult for us to visualize all these things. So what I will do, I will first start with the implementation of this flow, that is how the instructor will be going to ingest the data into our platform. So what happens is, like, whenever a particular instructor is onboarded into our service, the instructor also have to go through the login process. So from the instructor aspect also, he have to first log in into our application, and thereafter the instructor can upload the content into our network. So here what will happen, sign up request will also be coming from the instructor also, and the request will also land in this user service. So you can easily create two different services, one for the user service, one for the instructor. But to keep it simple, what I'm doing, I'm just creating one service called as a user service, and with the help of this user service, both the onboarding of the user as well as the instructor will be done. So the onboarding request is coming from the instructor, and thereafter, based on the request URL, this API gateway is routing our traffic into our user onboarding service. Clear? But here, if you look carefully, the metadata that we have saved over here is typically for the user. There is no way we can identify a basic user from an instructor. So here I will create two tables, one for storing the information of the user and another for saving the information of the instructor. So let's see how the schema structure of the instructor database will look like. So these are more or less all the metadata that we need for our instructor. That is the same user ID, name, verification status, phone number or the email number, password, average rating, student count, course count, and the status. So if you go into a profile of an instructor in Udemy or in Coursera, you will be seeing that it gives you some of the important metadata, that how many courses a particular instructor have launched, how many students are enrolled under him, and all this information are there for a particular instructor. And that is why, to capture all this information, we are introducing all this attribute over here. But apart from that, here if you see, there is one more important thing, and that is called the verification status. And why it is needed? So actually this question was asked during my interview, that if we want to validate a particular instructor with some documents or proof, how we will implement that. And for that, to validate a particular profile of the instructor, we need an additional field called as a verification status, where you can upload any PAN card, Aadhaar card, or any government proof that is there in the outside country. So that is how we should validate a particular instructor, whether he is a verified user or not. I hope this is clear that why I have introduced this verification status over here. But remember one thing, just by introducing a verification status will not solve the problem of how you are doing the verification using the Aadhaar card or PAN card. There is one more service that you have to invoke for the verification. That is, here in India, we can validate a particular citizenship of a user with the help of this website, that is with the help of this UDI website. So it has some open API endpoint by which you can validate a particular user. So here, to verify a particular instructor, what we have to do? Here we have to call a third-party service, that is the UDI website for India. And once you pass all the important information to this service, like your Aadhaar card, your date of birth and mobile number, it will just give you in the response whether the user is verified or not. And whatever the flag it returns, you will keep the flag in this field, that is the verification status. I hope this is clear that how you can integrate the verification over here. So this flow is not needed for the normal user. A normal user can easily do a sign up with the help of this user service. But in case of the instructor, here we have to invoke one more service, that is this one, which will validate whether the user is verified or not. I hope this is clear that how we are onboarding both the instructor as well as the user in our application. Now, since we have already onboarded the instructor in our application, now the next thing is like the instructor will be uploading their course. Now, how they will be uploading? There are few steps by which he can upload the course. So a course can be divided into two categories. So for example, if you are going with the Udemy course, there we have the textual course as well as the video course. Means for a particular video, there will be some description and the metadata for a particular video, as well as there are some quiz and assignment linked to a particular lesson. So let's now see how the instructor will upload all those data in our database. So here, if you remember, during our high-level designing, we have introduced a catalog service with the help of which the instructor will be uploading all the metadata related things into our database. So for example, I want to release an entire course on system designing on Udemy. So what I will do? I will first create a course called as a system designing, and after that I will add some description into it. So all those metadata or the textual information will be saved into our course database. Now, once the main course or the playlist has been created, what I have to do? I have to create how many chapters that will be there for this course. So for example, this is my 19th video on system designing. So if I want to create all those 19 videos or 19 lessons on Udemy, what I have to do? I have to first create the first lesson, that was nothing but the URL shortening. So I will first create that. I want to create a first course with the title, description and all these things. And all this information will go into this course database. And thereafter, once I have created the first lesson, that is the URL shortener, then what I have to do? I have to upload the video into the system. And how the video will get uploaded in this system? That is with the help of the media uploader service. And I hope right now, after seeing my last few videos, that is system designing on the Google Drive and system designing of the OTT, I think I do not have to repeatedly tell that how a video gets divided into chunks and how each and every chunk will get uploaded in the system. So this is completely a file uploader service where there will be multiple systems that will get involved, means a chunker service, our encoder service and all those things, and all those things will divide this entire video into multiple chunks and multiple pieces, and it will upload it into our backend system, that is nothing but the blob storage. And as I have already told you in my last video, that the uploader service will not be responsible to upload this chunk directly from the instructor to the blob storage. Rather, it will just create a signed URL, and based on the signed URL, this instructor will directly upload those chunks from here, means from their local, into this blob storage. So if you are not clear about what I'm saying or how this video gets uploaded into the blob storage, I would highly request you to go through my last video, that is the Google Drive uploader, and there I have told in detail that how the metadata is getting generated and how we are doing all these things. And remember, for this interview, that is while you are designing this Udemy, you do not have to tell your interviewer that how all these things are working, because during my interview also I told the interviewer whether I need to describe that how the video file is getting chunked and all these things. So he told that you do not have to tell all these things, just assume that there is some uploader file by which you are uploading those heavy video file from the local into the blob storage. So here we will keep it simple, that is with the help of this media uploader service, all the videos are getting uploaded within this blob storage. Clear? And here blob storage is nothing but the S3 bucket we will be considering over here. And what are the files that we will be storing over here? We will be storing the video file that will be in the form of the chunk. Also, we have to save some other heavy files like the thumbnails, some attachment, and all those course related things which are in heavy size and which cannot be persisted in the database. So all those flat files should get uploaded in this S3 bucket. Clear? So let me just here write all the things that will be stored in the S3 bucket. So here you can see I have mentioned it clearly that this S3 bucket will have the videos in the form of the chunk, and all this video will be processed and transcoded. So as you already know, while I was designing the OTT platform, I already told you that each and every video are kept in different resolution, and based on the bandwidth of the client, we dynamically fetch that corresponding video file accordingly. Means if the bandwidth support a 4K video, we will render the 4K video at that time, and if the network drops by anyhow, we will render the 480 or 720p video. So all those things I have already discussed in my earlier video. I'm not going into the detail of how the video rendering will happen. But here if you look carefully, we have already uploaded all the videos and the metadata of the courses that are necessary for a particular course. But apart from this, there is some other metadata that also need to be uploaded. That is, for example, a particular course will have some assessment and the quiz. So all those metadata will also need to be stored in some database. So what I will do, I will just expand this entire designing a bit so that I can include some other services in between. So here what I will do, I will introduce one more database, and that is very much crucial, and that is nothing but a assessment or a quiz DB, which will have all the information of the quiz and the assessment of a particular user and a particular course. So all this information will be there within this quiz DB. And how we will ingest the data? So here with the help of this catalog service, the instructor will upload all the information directly into the quiz DB. So for example, for a particular course or for a particular lesson, set of questions that the user have to solve. So in this way, there will be some JSON mapping structure by which we will be saving all those information. So here if you see, we have uploaded the videos, we have uploaded the metadata, as well as we have uploaded the quiz that are related for a particular course. But the things does not end over here, because as I have already told you earlier, once an instructor uploads some courses into the Udemy platform, there is a set of admin or the moderator who first check whether the course is a valid or not, whether there is any vulgar language in the course or the video, and all these things goes through a validation process by some moderator or the admin. So here also we have to introduce that flow, that how the videos or everything will get validated before publishing globally in Udemy. So here what I will do, I will introduce one more service, and that is called a course moderator service. And this course moderator service will do a couple of things. That is, first it will talk with this course database to see what are the metadata of the course that the instructor have uploaded, and thereafter it will also talk with this S3 bucket to see what are the videos that he have uploaded, and also he will see what are the quiz that the instructor have uploaded. So whatever the information of a particular course have been uploaded by the instructor, everything will get validated using this course moderator service. And who will invoke this course moderator? It will be done by the admin or the moderator of this Udemy platform. So here there will be one more actor or one more client or user of our application, and that is nothing but the admin or the moderator. And this admin or the moderator will also use the same load balancer and the API gateway, and with the help of this API gateway, it will simply hit this moderator flow by which it can validate that whether a course is valid or not. And once all this validation is done, what it have to do? It have to only accept and publish it globally for all the users. I hope right now we are clear with how the things or how the flow is working. Now let's see what are the metadata that we need to store within this course DB, because this course DB will contain a lot of tables where all the metadata of the course will be there. So let's now see what are the tables that we need to persist within this course database. So let me first list down all those tables. After that, I will let you know in detail that what is the functionality of each and every table. So here, if you look carefully, these are primarily all the three tables that we need over here in the course database. Number one is the actual course table, which have the course ID, the instructor ID, the title, description, category, label, thumbnail URL, and all the metadata that are needed to identify a particular course. After that, each and every course will have some pricing. And here you can see we are having a price table. So here we have the course ID, price amount, and the currency. Similarly, here we are having a course stat, means how many people have enrolled to the course, what is the rating of that course, and all this review and the rating information we will be saving it in the course stats table. I hope this is clear that what are the information that we need to persist in the course DB. Along with that, what we have to do, here if you look carefully, we have introduced a quiz DB or the assessment database, where we have to keep all the information of the assessment or the quiz the student have to perform. And for that, here we are having two tables. One is the quiz table and another is the questions table. So let's see what are the information that we have to store. So here you can see that for a particular course or a particular lesson, we can easily list down a quiz. And for each and every quiz, there can be multiple questions that are there in our database. So for example, for a particular quiz with ID 001, there can be multiple questions that can be there within a quiz. So there is a one-to-n mapping over here between the quiz and the question. I hope this is clear that how we are saving all this information in the database. And if you just tell me which type of database we will be using, obviously you can see that this is quite a flat and the relational data, and that is why we will be simply going with a Postgres or a MySQL solution. And as I was already telling you here, if you look carefully, since there are a lot of joins that need to be done for fetching a particular course, and that is why we had our service called as an aggregator CDC pipeline, which will actually join all this information together, and it will create a single document file, and it will fetch it within this Elasticsearch so that the searching can be done in the most optimized time. I hope right now you are clear with the flow, why we have introduced this aggregator service over here. Now let's take an example that a particular student have searched a particular course with the help of this searching engine, and there may be 10 to 15 courses that got enlisted in the front end. Now, after seeing all the metadata and everything, what the user or the student will do, he will have to first enroll into that course. And whenever it is a paid one, obviously it have to go with the payment gateway. And if it is a free course, it will be a direct enrollment. And why this step is important? That is because a student cannot have access to all the courses. He or she can only open the course that he have paid for or where he have enrolled. So here we have to save some information about the permission that which course can be accessed by which user. And that is why to introduce that permission, what we have to do, here we will be having our course enrollment database, which will have all the information of the student and the course on which they have enrolled. Clear? Now let's see how this entire flow will work and how we will be integrating it with the payment gateway. So for example, the user have selected a particular course on system designing. Now what will happen if the course is free? The user will click on the enroll button and the request will directly come into the course enrollment DB that this is a free course and the user have full right to enroll to that course. But if it is a paid one, then what will happen? Once the user try to open that course, our front end would tell that you have to pay the amount to view this course. And that is why once he clicks on pay, the request will go into our payment service and thereafter it will go into our payment gateway for doing all the transaction with the bank. And how this payment gateway actually works and how all these things happens with the bank, for that also I have already created a video in my playlist. So I will also skip the payment gateway over here. So what happens is like once the request go into the payment service, From this payment service, the payment service will internally call our payment gateway by which the actual transaction with the bank will take place. So here we will be having our payment gateway, and how it works I have already covered in the video 70 on my playlist. Now once the response comes from the payment gateway, whether it's a fail or a success payment, the request will come into our payment service, and we have to capture that information that there is a payment that had happened in our system, as well as we have to give the permission to the user. And let's see how it is done. So what happens is, like, once the information that the success request comes into the payment service, this payment service will not make two calls between the course database as well as the payment database. Because if you understand it correctly, if you try to make changes in two databases, there is a possibility that one of the call will fail. And if one of the call fails, then that is a very critical issue over here. Because if you understand it clearly, for example, this request of updating the payment DB is done successfully. So what will happen? The record will be there in our payment DB that user have purchased the course. But in case this request fail for the student enrollment, then what will be the scenario? That is, the user have done the payment, but he have not got the course which he have opted for, which will be a very bad user experience. So what we will do, we have to handle it in a different way. Means we cannot update two separate databases in the same time. Rather, here in the payment DB, we will create two tables. One is the payment table and number two is the payment outlook table. So let me first write down all these things. After that, I will tell you how the things are working and why we need two tables over here. So here, if you look carefully, I have introduced two tables. One is the payment table and number two is the payment outlook table. So whenever a payment is successful and we receive a successful message from the payment gateway, this payment service will make an atomic call into this database, and it will try to update both this table together. That is the payment DB as well as the payment outlook table. Now how these two things are different? So the payment table will have all the information of the payment, and this payment outlook table will have the information of the payments, as well as there will be some other metadata information that will help us to give the student the access for a particular course. So what will happen? Once a particular entry comes into the outlook table, there will be a CDC pipeline that will get involved. Means whenever there is an update in the database, that is in the payment outlook table, the request or the event will go into a CDC pipeline and it will get published into a Kafka broker. Let me first tell all these things. After that, it will be very easy for you to understand. So here what will happen? Whatever the changes that have happened, means for example, you have purchased the course, that event will get published into this Kafka broker. And once this event comes into this Kafka broker, we can easily understand that someone have made the purchase. And once you made the purchase, what will happen? Two things will happen. One, there will be a notification service by which you will get notified with the help of a mail or the textual format that the payment was successful. And along with that, there will be one more service that we have to introduce over here, that is called as a permission sync service. So let me first write that thing over here. After that, I will explain you what I'm trying to do. So here, if you see, we are having a permission sync service. Means whenever you have purchased a course, for example, a system designing course, the event first comes into the Kafka broker. And once the event comes into the Kafka broker, you will get a notification with the help of this notification service that you have purchased the course. And once the event comes into the Kafka broker, this consumer service that we have introduced over here will read that event from here. Means that there is a new student who got enrolled for this course. And based on the purchase ID, the course ID and the student ID, what this permission sync service will do? It will simply make an entry in the course enrollment DB. Means for this particular course, these users have the access. I hope this is clear that how we are providing an access of a particular course to a user. Now, if you think it logically, there can be one more solution to this problem. That is, once the payment is done successfully, we can simply push that event directly into the Kafka broker, and one more event will go into the payment database to update the payment related information. So that is also a fine approach, but there can be a chance of failure on that line. Because here, if you look carefully, what we are doing with the second approach, that whenever there is a purchase, we are sending an event directly into the Kafka broker. And in case the Kafka broker goes down, before this consumer service consume it and insert it in the database, then what will happen, that transaction will get completely lost. And since here this is a consistent system that we have to create, and that is why what we are doing, instead of putting the event directly into the Kafka, we are putting first into the payment database, so that if the Kafka fails by anyhow, we can simply get the event from the Outlook table which have not been consumed till now. And how we will get to know that what are the events that have not been consumed? That can be easily done with the help of some of the additional metadata in this Outlook table. Like the updation time, the consuming time, means the offset and everything will be present in this Outlook table. And hence we can say that this system is resilient and it is consistent. Means whenever there is a payment, obviously the request will go into the payment database, and thereafter the CDC pipeline will get invoked and it will get published to the Kafka broker, and from this Kafka broker there will be a notification that will get sent, as well as this permission sync service will consume that event and will update that event into this course enrollment DB. I hope this is clear that how this entire thing is working. And if you want to know what this design pattern is called, this is called the Outlook design pattern. Now let's see what are the tables that should be there in this course enrollment table. So this course enrollment table will have all this metadata, that is the access ID, user ID, the course he have purchased, the scope, means whether it's a lifetime subscription or it is a subscription model, what is the status, means whether it is active, revoked or expired. After that, what is the purchase date. Similarly, here we will be having a payment database or an order database where we will be having the information about the payment as well as the order. I hope this is clear that what are the information we have to store in the course database as well as in this payment DB. Now what will happen, once the user have made the purchase, he will get a notification that the payment is done successfully. And once he get the access, what he want to do, obviously he want to open the course. And once he open the course, the request will come into our video playback service. Means obviously a particular course will have video and thus it will hit our video playback service. Now, before fetching the video from the S3 bucket, this video playback service have a crucial role. That is, it first have to check that whether the user have the access to that course or not, because here we have to restrict the course for a particular user. Means if he is not authorized, he should not be able to see the video. And that is why, to implement that, when a user is opening a video or opening a course, the request will first come into this course enrollment database, and if the user is a valid user, then what will happen, this video playback service will give in the response a manifest file to fetch all the videos. And what is this manifest file and how the manifest file look like? For that you have to see my video on the OTT platform, which I have already told you in detail that how a manifest file looks like, and how by reading the manifest file, the front end or the video processor that is there in the client read the videos from the S3 bucket. Clear? So here if you see, this playback service is doing a critical job. That is, it is first checking the access and thereafter it is sending the manifest file to the client or to the front end. Now here if you look carefully, once the client receive a manifest file, or for example, if you take an example that it is a URL of the video, it is not possible that for each and every video we will be hitting this S3 bucket, because it will be a huge network journey for a user sitting in India to see a video that is there in the S3 bucket of US. So to optimize that, what we have to do, here we have to introduce one more component called as a local CDN. And what this local CDN will do, once the video playback service return a manifest file, this front end will first check that whether the video is present in the CDN or not. And if the video is not present in the CDN, what will do, the CDN will hit this S3 bucket over here to fetch that file from the S3 bucket if it is a CDN miss. I hope you know how the CDN actually works. So this is nothing but a call that will go to the S3 bucket if it is a CDN miss. But if the video is already present in the CDN, the user do not have to hit this S3 bucket again and again to fetch each and every chunk of the video. Rather, it will directly go into the CDN library and it will get the video with negligible latency, which was another core non-functional requirement that we have defined over here. I hope this is clear until this point. Now let's take an example that a user has seen some of the video. Now a set of questions or an assignment have opened for the user to solve. Now how we will submit it into our backend? So for that, here we will be having one more service called as an assignment service. And with the help of this assignment service, whatever the questions that the user have answered will go and get persisted in this quiz database. So this quiz database have information about all the metadata of the quiz as well as what is the response of the student for each and every quiz. We have to also persist it in this quiz database. So this quiz database will have information of everything. I hope this is clear that how the entire flow is working over here. Now here we are just left with two important things. That is number one, the user progress, and number two, the review and the comment section. So here if you see, this comment and review section is very simple. That is, whenever the user or the student want to leave a comment, it will simply hit this comment and the review service, and thereafter all the review and the comment will get persisted within the course database. But here if you see, there is one more important thing, that is the user progress service, which will track all the progress of the user. Means for example, a user is watching the video and thereafter he logs out. Now in the next phase or the next session, when he log into our application, then the video should get played from that point, or it will show that what percentage of the course he have completed. And to capture all this information, what we have to do? We have to do something else. That is, we cannot directly get this information and persist all the information into our progress database. Because if you understand this point clearly, to track a particular flow of the user, means what he is doing or how many seconds he have watched for the video, what we have to do, from the user front end, on each and every 10 seconds, we have to keep on sending a request into our backend, that on the 0th second, this is the status of the user. On the 10th second, this is the status of the user. So on each and every 10 second or 15 second, there will be a request that will be coming from the front end to the back end. And if we keep on saving all this information in the progress database, that will be a huge amount of data that we will be saving. And if you understand the logic clearly, here we do not need the information of the user of each and every second. Rather, what we need the last information, that at the last moment, what was the progress for the user. And how we will do it? And let me show you how we will do it. So here what I will do, I will just move this progress database a bit downward so that I can introduce some other component over here. Now what will happen, whenever the user is watching a particular video, what will happen, the event will get triggered from the front end. And whatever the event is coming from the front end, we will simply dump it into a Kafka broker. Now why we are doing it, I will let you know very quickly. So here there will be a Kafka broker which will capture all the user progress related information over here. And from this Kafka broker, what we will do, here there will be our progress database. And to ingest it into our progress database, what we need, here we need a consumer service. And the responsibility of the consumer service is just to update the last event that had happened. So let's take an example. I am watching a video and on each and every 10 seconds, there is an event that is getting generated in the Kafka broker. And since I do not need the information of every 10 seconds, what this consumer service will do, it will run a bad job maybe after each and every minute. And it will simply read last timestamp of the event. And it will just upload that information into the progress DB. So I hope this is clear that how we are filtering out the data and we are not inserting all the seconds of information of data into this progress database. But in case you need an analytical job to see how the user is behaving or how the user is interacting with the system, then you can simply store those information with some other flow into some analytical job. But as of now, since here in the progress DB, we do not need all this information, this is how we are segregating the information and we are only capturing the event that is necessary to us. Let me just right now show you how this progress database will look like. So here if you look carefully, this is how the progress DB will look like. So here we are having the user ID, course ID, the video ID which the user is seeing, the duration second means how many hours he have watched the video, the last timestamp till what he have seen the video, and all this information we are saving it in the progress DB. Now there is one more thing, that is once the user logs in into our application for the second time, then what happens? The request will first come into the user progress DB. From there, this user progress service will directly fetch till what timestamp the video have been watched or what is the progress of that user for that course, and that information will get rendered in the front end. So I hope this is clear that this user service is doing both the thing, that is submitting the information of the metadata into the database, as well as it is fetching the last timestamp or the percentage of the completion from this progress database. So here, if you look carefully, we have almost covered everything that we have taken into consideration into our functional as well as into our non-functional requirement. And I hope that you have thoroughly understand each and every flow that we have introduced over here. But as I've already told you at the very beginning, there was another functional requirement follow-up question which my interviewer have asked me. And that is, for example, we are making this application as enterprise level. So for example, there is an enterprise version of the Udemy. And there are multiple organizations like Microsoft, Google, Flipkart who want to get onboarded into our application, and they want to tell their employee that these are the courses that his employee have to complete within a particular timestamp. So here what the interviewer is actually asking, so here he is making it clear that we have to make it an enterprise level application. And while I was designing that also, there was few of the follow-up questions that he was trying to get it clarified. But just let me tell you how we can enhance this design and how we will be introducing those functionality. So the first requirement that he have given is like, so for example, I am the admin of the Microsoft and I want to get onboarded in this Udemy platform. So what will be the onboarding flow? So very simply, there will be another onboarding flow just like the user service. There will be one more onboarding service for the organization. And once the organization is onboarded, the next follow-up question was, for example, I want to see the landing page of each and every organization should be different. So for example, if I am opening the admin panel or the course from the Walmart, then the landing page should be different. If I am opening from Microsoft, it will be different. So how we should implement that? For that, what I have told that we have to create some templating over here, and all those template for each and every organization, we have to store it in some database. And how we can store the template? We can simply store the template in the form of the JSON. And once the employee from a particular organization is coming with his corresponding SSO, we will first check the metadata in the header that from which org he is coming, and based on that, we will open the landing page for that user. I hope that is clear. But there was few more follow-up questions after that. That is how we will segregate the data from the Microsoft and the Walmart. So here, if you look carefully, I have created a single database called as a course DB. And with my implementation, what will happen that all the information of the Microsoft and the Google and whatsoever, all the courses will stay together in a single database. But the interviewer wants that it should not be there in a single database, rather it will be different with the different organization. So what his real ask was, he want to just clarify that whether I have the knowledge of sharding and partition, and whether I have the knowledge of the tenant-wise segregation of the information or not. So here at that time, you have to just tell that how you will shard the data based on different organizations, so that no two organizations are sharing the same database or something else. And the next follow-up question was pretty interesting. It was not from system designing, rather it was from the networking question. That is, so here if you look carefully what we have designed, we have a simple Udemy platform from which each and every user across the globe can enter. But since this is an enterprise model, what he wants, like for Microsoft or for Google, there will be a separate dedicated URL that we will be providing. So at that time, I have to tell the interviewer about the concept of subdomain and the subnet, and after that I have to show the signature of all the URL, that how we will be distributing the URL based on the organization. So that was actually the follow-up question that had been asked after I have done the deep dive designing of this system. I hope right now you are clear with the entire concept that how we should create this EdTech platform like Udemy or Coursera. And if you have liked this video, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you in my next video where we will be solving another problem on system designing interview. So see you on our next video. Thank you.